So this is question 11. We are given this equation of the curve, and we have also been given that the curve has a stationary point, and we are required to find the value of k. So this is the first part of the question, so I'm going to give you the solution. Solution is given the curve as a stationary point. This means this stationary point would occur only when dy over dx is equal to 0. Now consider y being equal to k times of 3x negative k raised to the power of negative 1 positive 3x. You rewrite this as y is equal to k over, in fact you don't have to rewrite, you can directly differentiate. So differentiating with respect to x we get, so this is going to be dy over dx is equal to, you differentiate this, you get negative k times of 3x negative k raised to the power of negative 2. Differentiating 3x would give you 3. This differentiation would result in 0. So positive 3. Now for dy over dx is equal to 0, what do we get? We get negative k times over, I'm pushing this down. So you already have a 3 there, so I'll place the 3. And this is 3x negative k raised to the power of 2. Positive 3 is equal to 0. Now you can move this to the other side. This would give you negative 3k over 3x negative k the whole squared is equal to negative 3. So these two will become positive. 3 can be cancelled. So you cross multiply, you get a value like this. K is equal to 3x negative k the whole square. Now you take the square on this side, it becomes square root. So 3x negative k is equal to root of k. Now the point is you will have to extract the value of k. So this would give you plus or minus, right? You need to cater to that. So you move this k to the other side, you get positive k. This is equal to 3x. So therefore x will be equal to k plus or minus root of k divided by 3. So this is the first part for the solution. Now the next part is we are given f of x being equal to 4 times of 3x negative 4 raised to the power of negative 1 positive 3x. For x being defined for all values greater than 3 over 2. Now it is stated that f as a stationary value at x is equal to a, and we are expected to find the value of a. Find the value of a. So we are given the function, and we are also stated that there is a stationary value at point x is equal to a. With this condition, x being greater than or equal to 3 over 2, we are expected to find the value of a. So let me move to the next side and do this question. So f of x is 4 of 3x negative 4 raised to the power of negative 1 positive 3x. Since f of x has a stationary point, this means d over dx of the function is equal to 0. So we have to find this. So differentiating with respect to x we get, so this is equal to negative 4 times of 3x negative 4 raised to the power of negative 2. Differentiation of 3x will give you 3. Differentiation of this 3x will give you 3. Now since df over dx is equal to 0, this means negative 4 times of 3 divided by 3x negative 4 raised to the power of 2 positive 3 is equal to 0. So this means negative 12 over 3x negative 4 the whole squared is equal to negative 3. Positive. and 3 divides 4 times, so you have 4 over 3x negative 4 the whole square is equal to 1. You cross multiply, you get 4 is equal to 3x negative 4 the whole square. You take the square to the other side, you get 3x negative 4 is equal to root of 4. You get two values, plus or minus 2, so I take 2 there, so 3x negative 4 is equal to 2. Move this to the other side, you get 3x is equal to 2 plus 4, so 3x is equal to 6. Therefore x is equal to 6 over 3, which means x is equal to 2. Okay, I am not taking the other value. Why? Because clearly it is given that x is greater than or equal to 3 over 2. So that means it's okay that we settle with x is equal to 2. Okay. Now the all important question comes is we need to find if it is if the point is maximum or minimum. So this is my functional value. So f dash of x is equal to what? F dash of x is equal to, this is the differentiation value, right? So let me write that down. So negative 12 over 3x negative 4 the whole squared positive 3. Now you differentiate this with respect to x again, and you find df over, or I would say find the double derivative f double dash of x. Now this is actually negative 12 times 3x negative 4 raised to the power of negative 2 positive 3, right? Now when you differentiate this, what do you get? You get negative 12 times negative 2 times 3x negative 4 raised to the power of negative 2 will become negative 3 times the differential of 3x will be 3, differentiation of this will be 0. Now negative negative positive, 12 times 2 is 24, 24 multiplied with 3 is 12 1 72. You push this down, you get 3x negative 4 raised to the power of 3. What is this? This is clearly greater than 0. So what do you mean by this? This means f double dash of x is positive. So what does this mean? This means the function is minimum. The point is a minimum point. What is it? Which point are we talking about? We are talking about the stationary point. X is equal to 2. So you can state that. So this means x is equal to 2 is minimum. Is a minimum point. You can box this. So that's a beautiful solution. So let's move on to the next part. Now this is the final part. We are given g of x is to be this. We are asked to find whether g of x is increasing or decreasing. Okay, in the previous case we are expected to find if the point is minimum or maximum. In this case we are expected to find if the function is decreasing or increasing. So for that we find g dash of x. So given g of x is equal to negative 1 over 3x positive 1 positive 3 of x. I'm going to rewrite this as negative 1 times 3x positive 1 raised to the power of negative 1 positive 3x. So this is g of x. Now differentiating with respect to x we get. So what do we get? G dash of x is equal to negative into negative. Negative 1 times negative 1 times 3x positive 1 raised to the power of negative 2. Differentiating 3x will give you 3. Differentiation of this 3x will give me 3. Negative, negative, positive. So I can rewrite this as 3 times 1, 3 over 3x positive 1 raised to the power of 2 positive 3. Now for every x greater than or equal to 0, 3x positive 1 whole squared will always be positive. Right? So this in turn means 3 over 3x plus 1 whole squared positive 3 will always be greater than 0. So this means g of x is increasing. So that's a conclusion for this question. Students, thank you. Enjoy your day.